For thousands of years, one brilliant reddish star has captured the imagination of skywatchers around the world. Hanging from the shoulder of the constellation Orion, it has inspired myths, guided travelers, and fascinated astronomers. But today, that same star is no longer admired only for its beauty. Scientists are watching it for another reason. They know it is living on borrowed time. The star is Betelgeuse, one of the largest and brightest red supergiants visible from Earth. Although it lies hundreds of light-years away, it shines so brightly that you can easily spot it without a telescope during the winter months. Its enormous size is almost impossible to imagine. If Betelgeuse replaced our Sun, its outer atmosphere would stretch far beyond the orbit of Mars and could even reach close to Jupiter, swallowing every rocky planet in the solar system. Yet despite its incredible size, Betelgeuse is approaching the end of its life. Unlike our Sun, which still has billions of years of fuel remaining, Betelgeuse has already exhausted the hydrogen that once powered its core. Now it survives by fusing heavier elements in a series of complex layers deep inside the star. This stage of stellar evolution is violent. Powerful currents of hot gas rise toward the surface while cooler material sinks back into the interior. The entire star expands and contracts in slow, enormous pulses. Its surface is constantly changing. Gigantic bubbles of superheated plasma, each larger than our entire solar system, rise and burst, making the star appear brighter or dimmer over time. For astronomers, Betelgeuse has always been unpredictable. But toward the end of 2019, something happened that shocked the scientific community. The star began fading. Not gradually over decades, but rapidly within just a few months. Its brightness dropped so dramatically that even amateur astronomers noticed the difference. Around the world, observatories quickly turned their telescopes toward Orion. Had Betelgeuse finally reached the moment everyone had been waiting for? Was one of the closest giant stars to Earth about to explode as a supernova? The possibility was thrilling. A supernova from Betelgeuse would become one of the greatest astronomical events ever witnessed by humanity. Scientists rushed to collect every possible observation. Ground-based telescopes monitored its visible light. Space observatories examined it in infrared wavelengths. Spectroscopes analyzed the gases surrounding the star. Every new piece of information was carefully compared with computer models. As more evidence arrived, the mystery slowly became clearer. The star wasn't collapsing. Instead, Betelgeuse had experienced an enormous surface eruption. A massive cloud of hot gas had blasted away from the star and drifted outward into space. As this material cooled, it condensed into dust. That dust happened to move directly between Betelgeuse and Earth, blocking part of the star's light and making it appear far dimmer than it really was. The event became known as the Great Dimming. It wasn't the long-awaited supernova. It was something almost as fascinating. For the first time, astronomers watched a red supergiant eject a huge portion of its outer atmosphere in remarkable detail. The observations revealed just how unstable Betelgeuse has become. Unlike smaller stars, its outer layers are only weakly held by gravity. Powerful internal forces can launch enormous amounts of material into space, creating expanding clouds of gas and dust around the star. These eruptions are not unusual for stars nearing the ends of their lives. In fact, they may be an important part of the process that prepares a massive star for its final explosion. Although Betelgeuse eventually returned to nearly its normal brightness, the event changed how astronomers viewed the star. It became clear that Betelgeuse is not quietly fading into old age. It is an active, restless giant undergoing dramatic changes that we are fortunate enough to witness in real time. But the biggest question remains unanswered. If the Great Dimming wasn't the beginning of the end, How close is Betelgeuse to becoming one of the most spectacular supernovas the Milky Way has seen? If Betelgeuse isn't exploding today, then what exactly is happening inside this enormous star? The answer lies deep beneath its glowing surface, in a place no telescope can see directly. Every star exists because two powerful forces constantly compete with one another. Gravity pulls everything inward, trying to crush the star under its own weight. At the same time, nuclear fusion releases enormous amounts of energy, creating pressure that pushes outward. As long as these two forces remain balanced, the star survives. But no star has an endless supply of fuel. For millions of years, Betelgeuse has been burning through its nuclear fuel at an incredible rate. Unlike smaller stars such as our Sun, massive stars consume their fuel much faster, living brilliant but relatively short lives. After using up hydrogen in its core, Betelgeuse began fusing heavier elements one after another. Helium gave way to carbon, carbon to oxygen, and eventually even heavier elements formed inside the star. Each new stage lasted less time than the one before. The closer the star moves toward the end of its life, the faster these changes occur. Eventually, the core will become rich in iron. That is a turning point unlike any other. Iron cannot release energy through nuclear fusion the way lighter elements can. Once enough iron builds up, the outward pressure that has supported the star for millions of years begins to fail. Gravity suddenly gains the upper hand. The core collapses in a matter of seconds. Temperatures rise to unimaginable levels. The collapsing material rebounds in an enormous shock wave that tears through the star, blasting its outer layers into space at incredible speeds. This is a supernova. For a brief period, a single exploding star can shine with the brightness of billions of ordinary stars combined. If Betelgeuse eventually reaches that stage, it will become one of the most closely studied supernovas in history. Fortunately, despite the dramatic explosion, Earth is at a safe distance. Current scientific estimates place Betelgeuse roughly 500 to 700 light-years away, far enough that its supernova would create a breathtaking display in our sky without threatening life on our planet. For weeks, perhaps even months, the exploding star could rival the brightness of the moon and may even become visible during daylight. But light won't be the first signal to arrive. Long before the explosion becomes visible, an invisible flood of particles called neutrinos would race outward from the collapsing core. These tiny particles pass through ordinary matter almost effortlessly, allowing them to escape the star before light does. Around the world, enormous underground detectors are already waiting for exactly this kind of event. Deep beneath mountains, inside abandoned mines, and under Antarctic ice, scientific instruments are prepared to capture those first neutrinos, giving astronomers an early warning that a nearby star has reached the end of its life. Researchers also hope to detect tiny ripples in spacetime known as gravitational waves. Although these signals would likely be extremely faint, they could reveal valuable details about what happened during the star's final collapse. Together, neutrinos, gravitational waves, and light would allow scientists to study a supernova more completely than ever before. Yet despite decades of observation, one mystery remains unsolved. No one knows exactly when Betelgeuse will explode. It could happen thousands of years from now. It could happen much sooner. At the moment, astronomy simply cannot predict the exact timing. That uncertainty is what makes Betelgeuse one of the most fascinating stars in the night sky. Every change in brightness, every pulse, every cloud of gas drifting into space, provides another clue about how massive stars live and die. Modern observatories, including the James Webb Space Telescope, continue to monitor stars like Betelgeuse using infrared observations that reveal details hidden behind clouds of dust. Each new observation helps scientists build better models of stellar evolution and understand the final stages of these cosmic giants. When Betelgeuse finally reaches its last moment, it won't simply disappear. Its explosion will scatter enormous amounts of carbon, oxygen, silicon, iron, and many other elements across space. Those elements will eventually become part of new clouds of gas. From those clouds, new stars will form. New planets may emerge. And perhaps, somewhere in the distant future, new forms of life will arise from the remains of stars like this one. In that sense, a supernova is not just an ending. It is the beginning of another chapter in the universe's endless cycle of creation. For now, Betelgeuse continues to glow above us, shining from Orion's shoulder just as it has for countless generations. It is unstable. It is changing. And one day, it will transform the night sky forever. Until that day arrives, astronomers will continue watching, measuring, and learning from one of the most extraordinary stars in our galaxy.